I'm out here at a research facility out here on North Star Road, and as a complement or a supplement to the water use rate lecture, I'm standing here next to basically a weather station by which we can calculate evapotranspiration rates. And on this unit we can calculate wind speed, air temperature, solar radiation, and today it's about 50% cloudy. All the measurements that you need to use, besides some other ones, for the Penman-Moncrief equation. So this data is all gathered in. Temperature, today it's a pretty hot day, it's about 94 degrees. The humidity, the wind are all inputted in that we collect, and then it gives an ET rate, or an evapotranspiration rate, for that day. Now in the lecture we talk about reference ET, which means across the state or across the country, weather stations are hooked up through state or local government and also federal government, and they make these measurements using an area, whether the predominant one is using grass, and that grass as a cover is maintained at 4.7 inches or about 12 centimeters. And then what we do from all that data we gather, they put in a crop coefficient, which for cool season grasses can be from 0.8 to over 1. Usually we're looking at 0.8 to 0.95 or 1. We multiply that to correct for that ground cover, and that's the turf ET rate for that day or that time. Now here, where this is obviously a local weather station, the turf cover is maintained at a much lower height of cut than 12 centimeters. So in this case, although the quality of it's not that great, not compared to the creeping bentgrass green, actually the measurement we're getting off, that we would call quote-unquote the reference ET, is pretty close to the ET of that turf. All right? As you can hear the wind coming through, no doubt. Today, I should put in the actual ET, and I'll probably add that, but given how hot it is, although about 50–60% cloud cover, so the solar radiation isn't that intense. Wind increases transpiration or evaporation too, and so does temperature and solar radiation. The relative humidity is pretty high for this time, so it actually can depress the transpiration or the ET rate. And again, as I mentioned in the lecture, when we talk about evapotranspiration, we're talking about transpiration, the water coming that the plant is emitting and leaving through stomates as a cooling process. And then we also have evaporation, water from the soil surface or from the leaf. The vast majority of, or the largest component of evapotranspiration is transpiration. Now from this data that we collect, and we know the ET rates, what we can do is predict or time our irrigation scheduling. Put a video in real quick, and so we know how much water is being lost by that turf situation, what it needs to be brought back up to field capacity or to the quality of turf we want. That's that ET rate, and then we can adjust our irrigation to put the proper amount of water down.